Hi, welcome back to Geometry, Chapter 3, Perpendicular and Parallel Lines. This is Section 3.3, Proving Lines Parallel. Our objective in today's lesson is to determine whether two lines are parallel. It's essential that you understand you can use certain angle pairs to decide whether two lines are parallel. Important to today's lesson is the definition converse. If you remember from Chapter 2, this was when we switched the hypothesis and the conclusion of a conditional statement. An example of this is below. If a triangle is a right triangle, then it has a measure of 90 degrees. That's the conditional statement. The converse of that conditional statement would be, if a triangle measures 90 degrees, then it is a right triangle. So what we did there was we switched the hypothesis and the conclusion. It made it the converse of the original conditional statement. It's important today that you remember this word converse because we're going to investigate the converse theorems of the postulate and theorems that we talked about in the last section. Using your note template, you could fill in the notes, or if you don't have the note template, you can download it from Edline, or you could just use paper and take traditional notes. The first theorem we're going to talk about today is Theorem 3.4, converse of the corresponding angles theorem. Write the theorem down. If two lines in a transversal form corresponding angles that are congruent, then the lines are parallel. You'll notice that this is the converse of the statement that we had in the last section. The last section we talked about if two lines are parallel, then their corresponding angles are congruent. In this section, we're exploring the converse of these statements. If two lines are cut by a transversal that forms corresponding angles that are congruent, then you know the lines are parallel. So draw the picture so you can see the example. If angle 2 is congruent to angle 6 in this picture, we have lines L and M, line L and line M. They're cut by this transversal. If angle 2 is congruent to angle 6, then you can prove that line L is parallel to line M. Remember that two lines like that are the symbol for parallel. So because the corresponding angles are congruent, then you know those lines are parallel. The next theorem that we have is Theorem 3.5. It's the converse of the alternate interior angle theorem. And this theorem states, if two lines in a transversal form alternate interior angles that are congruent, then the two lines are parallel. So again, it's the converse. We've switched the hypothesis and conclusion of the alternate interior angle theorem. You'll remember from last section, that said, if two parallel lines are cut by a transversal, then the alternate interior angles are congruent. Well, the converse states, if two lines are cut by a transversal so that their alternate interior angles are congruent, then the lines are parallel. So write this down. The next theorem that we have is Theorem 3.6, the converse of the same side interior angles postulate, or another name is consecutive interior angles. If two lines, so again we have line L and line M, and a transversal, form same side interior angles that are supplementary. So if you know that the measure of angle 3 plus the measure of angle 6 equals 180 degrees, then you know these lines are parallel to each other. You can prove that these lines are parallel. In the last section, we talked about if two parallel lines are cut by a transversal so that the consecutive interior angles are supplementary. Now, we're talking about if two lines are cut by a transversal and the consecutive interior angles are supplementary, then our conclusion is the lines are parallel. So that's what's switching from this section to the last section. In the last section, we knew the lines are parallel. In this section, we're proving lines are parallel because we know these relationships to be true. The last theorem that we have is the converse of the alternate exterior angles theorem. if two lines are cut by a transversal so that their alternate exterior angles are congruent, then you know that these lines are parallel. Remember, those arrows on the line symbolize parallel, not congruent. So again, take note here. If two lines in a transversal form alternate exterior angles that are congruent, then you can prove the lines are parallel. If at any time you need to, go back and pause this video so that you can take notes and write these things down. Now you've taken all the notes for today, let's use these concepts to identify parallel lines. Which lines or segments are parallel? And let's justify your answer. Well, in this first example, we know that this angle is congruent to this angle. If I ignore the rest of this picture, I'm ignoring this line here, I'm going to ignore it, then those two lines are cut by this transversal. And what I have there are alternate exterior angles. So, using the alternate exterior angles converse, that word's important here, converse, I can prove that line AB is parallel to line CD. That's what you can prove, that line AB is parallel to line CD, because the alternate exterior angles are congruent. Now notice you don't know anything about the angles over here, so I can't prove anything about line AC and line BD. I can only prove that line AB is parallel to line CD. So AB is parallel to CD because of the alternate exterior angles converse theorem. Take a minute and look at number 2. See what you can find. Pause the video. Looking at this picture, we can identify these two congruent angles, angle WXY and angle ZYX. If we're looking at this line WX and this line YZ, cut by this transversal XY, those are alternate interior angles, and if they are congruent, then we can prove that line WX is parallel to line YZ because of the alternate interior angles converse theorem. We can't prove any other pairs are, can we? Well, let's take a look. We know that WX and YZ are parallel because of the alternate interior angles converse theorem. Converse is the important word here. How about this pair? Can you prove that XC is parallel to YW? If they're cut by this transversal XY so that their alternate interior angles are congruent, are they also parallel? They are, using alternate interior angles converse, so we can prove both pairs are parallel. So again, using alternate interior angles converse theorem, we can prove that line WX is parallel to line YZ, and we can also prove that segment XC is parallel to segment WY, using alternate interior angles converse. Later this week, we're going to work on some proofs involving these, but for right now, we're going to prove Theorem 3.5, the alternate interior angles theorem. When you set out to prove a theorem, you cannot use that theorem. You can use everything else that you know, but you can't use the theorem that you're looking to prove. So here we're given that angle 2 and angle 3 are congruent. We want to prove that lines L and M are parallel. Well, how can we prove that? So remember, writing our proofs, we were writing 2-column proofs with statements on our left and reasons on the right. Our first statement is that angle 2 is congruent to angle 3. How do we know that? That was given to us. Now, the next thing that we know looking at this picture is what? We're trying to prove the lines are parallel. If we know 2 is congruent to 3, what else? What other angle is congruent to 2? Yeah, angle 1. Why? What are 1 and 2 to each other? That's right, they're vertical angles. So we know that angle 1 is congruent to angle 2 using the vertical angle theorem. Because 1 is congruent to 2 and 2 is congruent to 3, what can we say we know about angles 1 and 3? That's right, angle 1 is congruent to angle 3. Why? That's right, it's the transitive property of congruence. Well, last step. If we know that angle 1 is congruent to angle 3, what can we prove? That's right, we can prove that these lines are parallel. Because what are 1 and 3 to each other? That's right, they're corresponding angles. So using corresponding angles converse, we can prove that line L is parallel to line M. L is parallel to M using the corresponding angles converse theorem. It is essential that you write the word converse. These are corresponding angles, but you can't just write corresponding angles. You have to write converse because the corresponding angles converse theorem says if two lines are cut by a transversal so that the corresponding angles are congruent, then the lines are parallel. And that's what we set out to prove, that the lines were parallel. Whenever you're trying to prove that two lines are parallel, you're probably going to use a converse theorem. Example 3. Determine whether two lines are parallel. Are the lines parallel? Can you justify your reasoning? So, looking at these two lines in number 1, line L and line M, are they parallel? Well, are these angles something to each other? They don't have a relationship that we have a theorem for. They're same side exterior. But what I do know about angle 1 is that with the angle next door, it's a linear pair, a pair of angles that forms a straight line. So that would mean that angle 1 is 120 degrees using the linear pair postulate. And therefore, using what kind of angles are those? They're alternate exterior angles. So using alternate exterior angles converse, I can say that I know line L is parallel to line M. So this is how you would write that. I know the measure of angle 1 is 120 degrees using the linear pair postulate, and therefore I know that line L is parallel to line M using the alternate exterior angles converse theorem. It's important that you write the word converse. If you're not writing converse, then that's incorrect. Take a look at number 2. See if you can figure out whether or not line N and O are parallel and justify your reasons. Then unpause the video and see if you were correct. So if you take a look at angle 2, you know that angle 2 is 135 degrees using the vertical angle theorem, and therefore you can prove that line N is parallel to line O using the same side interior angles converse theorem. If you had that, you were right. Example 4, our final example. We're going to find the value of x for which G is parallel to H. Then find the measure of each labeled angle. So this is similar to what we were doing in the last section. If G is parallel to H, then how would you solve for x? And then find the missing angle measure. So take a look at number 1. If G is parallel to H, then these angles are what kind of angles? They would be corresponding angles. And therefore, 2x plus 16 would equal 126. So you would subtract 16 and get 2x is equal to 110, and then you would divide by 2 to get that x is 55. When you plug it back in, you would find that this missing angle is 126, which you knew because they're corresponding angles. Corresponding angles are congruent. They would make these lines parallel, and therefore x would be 55. Look at the next one. If line G were to be parallel to line H, then what kind of angles would those be? Those would be same-side interior angles. And if the same-side interior angles are supplementary, have a sum of 180, then these lines are parallel. So set up your equation and solve for x. Find the value of these angles. So if they were consecutive interior angles or same-side interior, then they would have a sum of 180. You would add them together to equal 180. You would combine like terms, add 2, divide by 26 to get that x is equal to 7. When you substitute in the value for x, 6 times 7 is 42 degrees. So this angle here would be 42 degrees, this angle. And then its consecutive interior angle, or same-side interior angle, must equal 180 when you add them together. So it would be 138. So 20 times 7 is 140, minus 2 is 138. If you substituted in the value and you didn't get the correct answer, then you would know you made an arithmetic mistake along the way. Let's try the final one. If line G were parallel to line H, then that must mean that these angles are what to each other? They're on the outside, on the opposite side of the transversal. So these are alternate exterior angles. If the alternate exterior angles were congruent, then line G would be parallel to line H. So pause the video, solve for x, substitute it in, and see if you get congruent angles. So you would set up this equation by saying 3x plus 6 is equal to 4x minus 18. You would isolate the variable, so I subtracted 3x, and then I added 18. So x is 24. When you substitute in that value, you would get 3 times 24 plus 6 is 78. 4 times 24 minus 18 is 78. So I know that my math is correct. These angles are congruent if G is parallel to H. Well, that's our lesson for today, and we will see you tomorrow in class. Have a great evening. Please remember, if you have any questions at all on today's notes, to ask them tomorrow in class. And while we're going over these different concepts, please have your notes with you so that you can refer back to them for the classwork.